Glaciers in every corner of our planet are retreating. It depends where you are, how quickly that's happening. But even in the polar regions, it's happening much quicker than we expected. But in Alpine regions, the glaciers that are there today, most of them won't be there in 50 years' time. And unfortunately, the pace of retreat is quickening too. So on average, Antarctica and Greenland are losing 5 to 6 times more ice today than they were losing in the 1990s. It's just increasing every year. And in total, Earth is losing about 1 trillion tons of ice every year. And that's not being replenished. It just goes into the oceans, causes sea levels to rise, changes the salinity of the oceans, and it also changes patterns of ocean circulation, disturbs the atmosphere and the weather patterns around the planet, and it's something we're going to have to adapt to. This feature was created when the ice sheet in Britain was melting away, and that took about 50,000 years in total to retreat across the British landscape from northern England up into Scotland. And that gives us an indication of how fast ice should be retreating in a glacial period. When we look at the changes we see today in Antarctica, it's happening about 100 times faster than that, and that's way too fast. And that's not normal. That's not something that they can withstand for another century or two. It's going to cause changes for the future. That's why it's really important to monitor the polar regions from space today and check whether the retreat is as we expected. There's been a step change in people's appreciation of how the ice sheets respond to climate change. In the first 2 IPCC assessment reports, it was understood that Greenland and Antarctica wouldn't really react to climate change. We now know, thanks largely to satellite observations, that that's not the case, that the ice is melting really rapidly. What's been absolutely essential is long-term satellite measurement programs. ESA's Climate Change Initiative is a really, really powerful program. ESA are really driving the launch of Earth observation satellites to study our planet, and it makes use primarily of their measurements that have been collected since the early 1990s now. So we have just about 3 full decades of observations, and we can go back to those earlier missions as well and check measurements to see how the ice sheets have changed over decades, which gives us more confidence to tell people that these changes aren't just a short-term variation and they're a pattern that's progressively changing and will continue to change in the future. So this is climate warming, it's not weather. But it takes a long time to get things into space, and not just to design them, but actually to then build them. It's a slow process and it requires continuous investment. Climate models and satellites in space looking at Earth, they're the cornerstone of what we've learned in 20 or 30 years. Those of us that have worked with satellite measurements have had to invent new ways to interpret them to study the planet. You have to go on the ground and check that what you think is a real measurement is actually a real measurement, and that's why we make routine field campaigns. There are some places that we have to return to year on year. We use them as reference sources, and when that's in the cryosphere, you get to see the landscape evolve throughout your own career. And Iceland's a really good example of that. There are glacier systems in Iceland that I visited 25 years ago that look very, very different today, and that's the real pace of climate warming and how it affects ice at low latitudes. The progressive retreat of the polar ice is really now unarguable in the satellite record. We've developed different satellite techniques to study each part of the cryosphere, and we can now confidently map them all from space. Unfortunately, the satellite record shows every corner of the planet is losing ice, and that can't be a consequence of slow glacial retreat. It's climate change. The ice sheets have switched from a position of being a slumbering giant throughout most of the last glacial period to reacting really rapidly to what we might think are small changes in the planet's temperature. So 0.5 degree centigrade warming
completely destabilizes parts of Antarctica and Greenland.
By the end of the century, we expect 400 million people around the planet to get flooded once each year as a consequence of the sea level rise that we're really bought into already. The challenge now is to give people some hope that there's a chance to arrest those changes and adapt to them.